Hi everyone, in this video we are reviewing for our Chapter 8 test tomorrow. So going through the problems for the first one, what's the degree of the polynomial? What's the degree of the polynomial? The degree is 4 because that's the highest exponent. And the next one, adding the polynomials 2x to the 6 plus 3x to the 6 is 5 of the x to the 6. So we're combining coefficients and keeping the exponent the same. For the next one, 5 apples minus 7 apples. Since those are exactly the same variables, we have negative 2 x third and y to the second, not changing the exponents. For number 5, combining like terms, 7b to the second plus 6b to the second, we have 13b to the second plus 9b plus 8, because the rest are unlike terms. For this one, we are distributing the negative. That's the key to that problem. So we'll get negative 4m to the second plus 5m minus 6. If I bring down my other terms, now I'm able to combine like terms, so I'll get negative m to the second plus 7m minus 14 for my final answer. For this one, multiplying polynomials, multiplying coefficients, adding exponents, I'll get 12n to the third, because there's a 1 there, plus 15n to the second. And this one, distributing to all three terms, we'll get negative 28y to the fifth minus, distributing the negative, 7y to the fourth, because there's a 1 there, plus 21y to the third, because the negative times the negative is the positive. For this one, pulling out the GCF, the most we can pull out is 11, and the smallest exponent is x squared. For this one, we can pull out a 3, and the smallest exponent is an x squared. Here we are factoring by pulling out the GCF. So pulling out a GCF of 48 and 30, we can pull out 6. The smallest exponent is w to the 6. So then it would be 8w to the third plus 5. Checking, if I distribute back, I would get 48w to the ninth plus 30w to the 6th. For number 12, we'll skip that. For 13, using FOIL, we will get 9h squared minus 18h minus 21h plus 42. So combining the middle terms, 9h squared minus 39h plus 42. Using FOIL on the next one, we'll get negative 12h squared minus 28h plus 6h plus 14. So together we'll get negative 12h squared minus 22h plus 14 for our final answer. Here, using FOIL, we'll get j squared minus 7j plus 7j minus 49. So together we'll get j squared minus 49. Here, using FOIL, we'll get 6x squared minus 18x plus x minus 24. Combining like terms, 6x squared minus 10x minus 24 for our answer. Here, multiplying out, we can write it twice, 2x minus 6, 2x minus 6. So using FOIL, 4x squared minus 12x minus another 12x plus 36. So we'll get 4x squared minus 24x plus 36. Here, writing it twice, x plus 5, x plus 5. So we'll get x squared plus 5x plus another 5x plus 25. So x squared plus 10x plus 25. Here, multiplying every combination. So the 4n times all three of them is going to be 8n to the third plus 20n squared plus 12n. Now distributing the negative 5 to all three terms, we'll get minus 10n squared minus 25n minus 15. So combining like terms, we'll have 8n to the third plus 10n squared minus 13n minus 15. Same concept for these, distributing 4k. We'll have 12k to the third minus 16k minus, that's k squared minus, again, minus 16k. Then distributing the 5, we'll get plus 15k squared minus 20k minus 20. So combining like terms, we'll have 12k to the third minus a k squared minus 36k minus 20 for our final answer. In these problems we're factoring, so since there's no GCF in the first one, we'll put 2 parentheses. Then we have x and x for first. For last, in order to get the negative, we have a positive and a negative. And to get 35, we could do 5 and 7. Because now for our outer, we'll get negative 7x. For inner, plus 5x. So together, negative 2x. And now all of FOIL works, so the problem is factored. For this next one, there's no GCF, so we'll have x and x for our first. But to get that positive 32, we need a double negative. And we can have it as 8 times 4 is 32. And then outer is negative 4x, inner is negative 8x, so together negative 12x, and it's factored. And this one, since there's no GCF, we can go to 2 parentheses and make FOIL work. So 2x times x is 2x squared. To get 4, we could write 2 and 2, or if I match the 4 up here and the 1 there, now my outer will be 8x and inner's 1x, so together is the 9x, and all of FOIL works. So I have my 2 factors. In this problem, since there's no GCF, we can factor it as 5x and x for first. For last, if I match up the negative 7 with the 5 and the 2 there, I'll get negative 35x plus 2x is negative 33x, and the problem works. Problem 25, since there's no GCF, I can go to 2 parentheses. Okay, so I can either do 1 and 6 or 3 and 2, so just guessing 3x and 2x. Then that works for my first. For my last, I could do 5 and 1, so I'll match up the 5 with the 2 and the 1 with the 3, and that way I'll get 3x plus 10x is 13x, and all of FOIL works. For this problem, again, I can do either 10 and 1 or 5 and 2. I'll guess 5x and 2x to make the first work. For the last, I can only do 1 and 1. So together we'll get 5x plus 2x is 7x, and the problem's factored. In 27, there actually is a GCF of 2, so if I pull that out and do times what is, I'll get x squared plus 13x plus 42. So refactoring the problem, but now I'm factoring x squared plus 13x plus 42. I'll get x and x make x squared. For last, I could do 7 and 6. Outer here's 6x and 7x is 13x, so all of FOIL works. My final answer has all three factors to it. This problem, if I pull out a 5, I'll have x squared plus 2x minus 8. So refactoring the part that I had, I'll have x and x and minus 4, positive 4 minus 2 makes negative 8. And my outer's negative 2x plus 4x is 2x. So I have the problem factored. In this problem, factoring x squared plus 14x plus 49, so making it work, I'll get x in x plus 7 and plus 7. Since this factor x plus 7 repeats, we'll write it x plus 7 squared for the final answer. Here for this one, I notice my first and my last are these perfect squares, so I'll start off guessing 3x and 3x. And minus 5 and minus 5. And for outer, I'll get negative 15x and another negative 15x, so together negative 30x. So final answer, since it repeats, is 3x minus 5 squared. For this problem, we're trying to make a 0x in the middle, x squared plus 0x minus 81. So we have x and x make x squared, plus 9 and minus 9 makes negative 81. Similarly, here's another special case. We have first and last, which are perfect squares, so 2x plus 5 minus 5. That's going to give negative 10x plus 10x is a 0 in the middle, so it works. 2x plus 5, 2x minus 5. These last problems, we have 4 terms. I'm going to factor by grouping by pulling out an x squared. I'll have x minus 4. In the second group, I'll pull out a 7, x minus 4. Putting the outside parts together, x squared plus 7, and bringing down one of the common factors of x minus 4. Here, pulling out in a 3, x squared, then I'll have 2x plus 9. In the second group, I'll pull out a 5, 2x plus 9. So putting it together, I'll have 3x squared plus 5, 2x plus 9. This problem, if I pull out a 5x squared, I'll have x plus 10. Now, my third term here leads with a negative. Because of that negative right there, I'm going to pull out negative 2 and get x. That switches the sign to positive 10. Because if I distribute back, I would get negative 2x minus 20. So I know that it works. So putting this together, 5x squared minus 2, and an x plus 10. This last problem, I'll pull out a 3x squared and get 2x minus 5. Then it starts with a negative, so I'll pull out the negative, pull out negative 3, get 2x, that switches the sign to minus 5. So together we'll have 3x squared minus 3 and a 2x minus 5. I can pull a 3 out of this, and I would get 3x squared minus 1, 2x minus 5. And finally, this factor right here, x squared minus 1, can refactor is x plus 1 and x minus 1. Multiply to get x squared minus 1. Bring down the 2x minus 5. So this final problem ended up with 4 separate factors. Good luck on your test tomorrow.